So on August 10th, 2015, Dr. Christine Figener posted a YouTube video showing her pulling out a plastic straw that had become lodged in a turtle's nose. As I'm sure most of you have seen this video, we know this video went viral and highlighted the harm that plastics pose to wildlife. However, this is really just the beginning. Plastics are made using a class of chemical called phthalates, and as humans, we are constantly exposed to phthalates because they're not actually bound to those products they're added to, and instead can easily leach out into surrounding surfaces. We can absorb phthalates through our skin, ingest them, and even inhale them. Once they get into our bodies, we metabolize them really quickly and then excrete phthalate metabolites through our urine and our feces. This type of exposure is really problematic because exposure has been linked with hormonal impairment that can lead to reproductive problems and developmental abnormalities. In the context of the ocean, where there's more than 5 trillion pieces of plastic floating around, this is really a problem. More plastic pollution there is, the more we would expect phthalate release and exposure to also be occurring. But how do we know that this is even a problem? At the end of the day, our oceans take up the vast majority of our planet. To answer this question, we turn to our marine mammal counterpart, the bottlenose dolphin. Dolphins are top predators with long lifespans, so their likelihood of interacting with any potential contaminant that there is present is really high. This makes them sensitive gauges for environmental health. In other words, you can think of them like a canary in a coal mine. I am fortunate to be working with a team out of Sarasota, Florida that has a year-round multi-generational resident dolphin population that they've actually been studying since the 1970s. My thesis aims to use the same principles that apply us of human health, or that inform us of human health, and apply them to dolphins to determine whether dolphins are being exposed to harmful levels of phthalates. To quantify phthalate exposure, I can measure those urinary metabolites that I had mentioned earlier and take concentrations of them. At the same time that we're taking urine samples, we also take blood samples from the dolphins to measure hormone levels. And this is used for a variety of research projects, my own included. Dolphin hormones tend to fall in a pretty tight range of concentrations. So any deviations from that range indicate that there's something going on. And if we can correlate those deviations from that range with detectable phthalate metabolite concentrations, we can get a pretty good look at whether we might be expecting phthalates to be interfering with hormone production. Testosterone, as an example, is really sensitive to phthalate interference and has been shown to significantly decrease following phthalate exposure. As we recreationally use the same waters and consume similar diets of fish and squid, the presence of dolphin health impacts indicate the potential for human health impacts as well. Plastic consumption has made our lives so convenient, but with this convenience comes a price, and we have to decide if that price is worth it, because after all, our health and the health of our planet is literally dependent on it.